exercise 3 and look at electric dipoles. So an electric dipole consists of two electric charges of equal magnitude and opposite sign. If the charges are q and negative q and are located at a distance d from each other, so you have q and negative q like that, and they're separated by distance d. And then the electric field at the point P in this figure, in the figure below here, is E equals to Q divided by D squared minus Q over D squared. This is capital D, and then plus lowercase d. Then this all squared at the bottom there. So yes, this is capital D distance from this charge Q. Alright, and now we're asked over here, so by expanding this expression for E as a series in powers of lowercase d over capital D, show that E is approximately proportional to 1 over d cubed when P is far away from the dipole. And I'm just going to move this figure above just to make it, I think it appears a bit better here. Put it here. And yeah, so there's the figure. There's the electric field at the point P. And yeah, this is just mainstream physics. I have my own take on it, but that's for another video. Anyways, let's keep going further. So now we have to go and check that and show that is proportional to 1 over d cubed, this electric field E, when P is far away. And we're going to expand this expression for E as a series in powers of d over capital D. So solution, we can rewrite the electric field equation to be able to use the binomial series. And yeah, because we have a squared here, we have it's squared at the bottom there, and this is a scenario that we could just factor all out so that the squares outside of it, and then make it as a binomial series, which is a 1 plus x to the power of k. And this will be apparent as we continue further. So let's write this out. So we can rewrite it as E equals 2, so let's just write our equation, q over d squared, like that, minus q over d plus d squared, like that. Alright, yeah, so we have this just fixed up a bit. So we're asked to, yeah, we're basically given a head to write it as powers of d over capital D. So what I'll do here is, because we want a 1 plus d over d, we're gonna equals 2, I'm gonna write this as q over d squared minus q, and then this bottom one right here, I'm gonna multiply this out, so d plus d, I'm gonna multiply this out by d over capital D over capital D. So then this one here, we could divide this one inside and leave the other one by itself, squared. Yeah, so we're not changing anything because we're multiplying by 1. So we put this inside both of them. So we're gonna get equals to q over d squared, and then minus, this is gonna be q over, now, so we're gonna have a d squared over there. So write this out. So this is going to be capital D divided by capital D is just going to be 1. The next one's going to be lowercase d plus capital D. And now we get this is going to be squared, and we could just square out the other d squared outside of it, like that. Now we could factor out the like terms, which is this one, and this one, and this. And we can just factor out the q over capital D squared, so that we get q over capital D squared, and then we have a 1 minus, yeah, so 1 minus, and then we have this over here. I'm going to write this on the top by putting a negative 1 there. So I'm going to put this as 1 plus d over capital D, and then this is going to be power of negative 2, like that. And this is going to be a square bracket, which is multiple brackets. And so we have this now, and now we have our scenario here where this is our x for binomial series, and this right here is our k. Yeah, so thus we can approximate this power to the power of negative 2. And again, the whole idea of Taylor approximation is going to remove this kind of function, just make it a strict polynomial. So let's just recall the binomial series. Recall binomial series like this. Or I'll just move this this binomial sign over here. And again, since we have this ingrained into our brains, or at least I have, and here just quickly just pause and move it over here, just because we need some more room when we write it. So recall the binomial series is going to be 1 plus x to the power of k, and now this one is equal to, remember, it's just going to be 1 plus kx, and then plus k times k minus 1 over 2 factorial. This is going to be x to the, this is x to the squared, like that. And the next one's going to be, this is factorial, plus, and then we have a k, k minus 1, k minus 2, then x cubed over 3 factorial, like that. And this one here is our x cubed, and it keeps going on and on. So we're going to have a plus, or move this over, plus dot dot dot. Yeah, so that's what we have is when we can approximate this. So d over d is gonna, our 1 plus d over d is our x. Actually, no, we get that off. This one is going to be our, that's our x. So we're only going to be approximating this right here as a binomial series. So that's d over d is our x, as we were asked here. So powers of d over capital D. So as a series of these powers. So what we have is, so thus we're going to write this as 1 plus d over capital D to the power of negative 2. Negative 2, and again, this is our x, this is our k. This is equal to 1 minus 2. K is negative 2, so negative 2x times it by, so this is going to be negative 2d over capital D. And then next one's going to be, well, it's going to be negative 2, then minus 3. So this is going to be a plus, a negative 2 over minus 3 over, this is going to be 2 factorial. Next one's going to be d over capital D squared. And now what we get here is, well, this one's going to cancel this. We'll get to that in a bit. So now next one's going to be negative 2, negative 3, and then minus negative 2 minus 2 is negative 4, and this is going to be x over, this is going to be 3 factorial, like that. This is going to be, yeah, this is going to be, let's erase this, this is going to be d over capital D cubed, like that, and plus dot dot dot. Yeah, and now we can simplify this over here further, but yeah, canceling this up we can. So negative 2 cancel here, and also this is going to be negative times negative, so that's going to be positive. This one's a 3 negative, so that's going to be negative. So we have a positive first, negative, and this is going to be positive, then be negative, and the next one's going to be 4 of them, and it'll be positive, and the next one's going to be negative, and so on. And also notice this 3 factorial is equal to 2 times 3. The next one's going to be 4 factorial, but then we're going to have, is going to cancel out with a 2, 3, and 4, and we're just going to be left with a 5. So you can see the pattern that arises. So this is going to equal to 1 minus, this is going to be 2 over d capital D, and then plus 3 d capital D squared. Next one's, all we're going to be left with is the 4, but there's a negative because it's 3 negatives there. Odd number of negatives, so 4. Yeah, this one cancels with this. This is going to be d over capital D cubed. And you can see the pattern. And it keeps going on, plus or minus. The next one's going to be plus, and the next one's going to be minus dot dot dot. Alright, so now that we have this, we can plug this inside our electric field equation. So let's go back to our electric field equation. So this one here, we got it up to this point, so we could replace now this power is 1 plus d over capital D to power negative 2. So we can replace it. So let's make this a bit more tight. Alright, so let's put this one like that. So thus we have E equals to, and let's put it all together, E equals to Q over D squared. So Q over D squared, and then multiply by 1 minus this whole thing. So we replace this entire thing with these this polynomial. So 1 minus, and then we have this over there. Let's put this bracket. Alright, so we 1 minus, let's put a bigger bracket here. So we're going to include all these ones. So we're going to throw this one all inside there. And so now what we get is, this is going to be 1 minus 2d over capital D squared plus 3 over d, d over capital D, like that. Let's just fix this up. It's just 3, and then plus, this is going to be minus 4 capital D over capital D cubed at plus or minus dot 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 bracket, close bracket. Alright, so now the next thing that's going to happen is, well, when you subtract this 1, this would just cancel with this, and then all these negatives are going to change up on us, and then we'll just write it for completeness. So those are going to cancel. This is going to be q over d squared. So now we could just write this as one giant bracket, and then this is going to be the negative inside there. This is going to be 2d over, so d over capital D squared, like that. Actually, here we have the mistake here. This is d over d. Yeah, this is the squared, and that's not. So this is not squared. This is going to be d, like that. And the next one's going to be, take the negative out, and then negative 3 d over capital D squared. Next one's going to be negative there, plus 4 d over capital D cubed. Next one's going to be minus plus, dot, dot, dot. And put a giant bracket like that. Yeah, so now we want to show that it's proportional to the 1 over d cubed when p is far away from the dipole. So when p is far away, that means d, capital D, is much bigger than the lowercase d. So what we could do is, well, as this gets lower, because if this is much bigger than it, then when you square it, becomes much bigger. I mean, this becomes much smaller than this part over here. So we could write this as this. So this part here, so I'm going to look at this case when capital D is much greater than lowercase d, then the d over capital D, yeah, so d over capital D squared plus, so when you square or plus anything else greater than it, this is going to go approaches 0. But it's also going to be much bigger than this d over capital D. So it's approaching 0, and it's this is much smaller. Let's put it the other way, because you're dividing by a larger number. So much smaller than d over capital D, like that. So then we can just ignore all these ones. We just approximate it by ignoring it. So thus we could approximate the electric field is approximately equal to q over d squared, and then we just get rid of all of these other terms. So it's going to be times by 2 d over capital D. So in other words, this part's going to equal to 2qd, and now we have, yeah, the qd, and this is going to be divided by capital D cubed. So in other words, it's proportional to 1 over d, 1 over capital D cubed, like that. And that is what we have. Let's put this better. Yeah, so thus when capital D is much greater than lowercase d, that is when p is far away from the dipole, then E is approximately proportional to 1 over d cubed. Or it's proportional, we're going to do that approximate, it is proportional to it. Yeah, so we're using this approximation. So it's proportional to it, 1 over d cubed when p is far away, and that is exactly what we were asked. Yeah, exactly what we were asked to do over here, show that it's proportional over to this one over there. So yes, and it's 2qd times by 1 over d cubed. So we can just write it like that, actually. So just write it more in this proportional sign to put the space. This is going to equal to 2qd, and then just multiply this by 1 over d cubed to show that it is proportional to it, like that.